Now I will tell you how to calculate the ionization energy for the given excitation energy of the hydrogen-like atom or ion. It means that you will be given the excitation energy of the atom, and corresponding to that atom you have to find the ionization energy. Ionization energy of hydrogen-like ion atom. I told you that this ionization energy is taken according to the electron which is found in some energy state, and this is the electron which is unpaired, or which is that electron which found in the outermost orbit of the atom. Let us denote it to be by this EI. So this is equal to your 13.6 Z square upon N square electron. And I told you that this ionization energy is always positive. So this N is taken with respect to 1. So this is how much? 13.6 Z square electron volt. This is equal to so much. Here N is equal to 1. And now excitation energy. Excitation energy. This Ex equal to En minus E1 into Z square. So now this Z equal to square root of Ex minus E1 upon, this is not Ex, only Ex, upon En minus E1. E1. This is not so much, where Ex equal to excitation energy of hydrogen-like ion atom. This will be given to you, and this En minus E1, this is now excitation energy of hydrogen atom. Right? Now I take the example. This will be better to understand it with the help of example. Calculate ionization energy of hydrogen-like atom for first excitation energy energy of 40.8 electron volt. Right? We are given the excitation energy of the hydrogen-like atom. Then you have to find the ionization energy of the same atom. So when we are given the excitation energy of the hydrogen-like atom, that for the same atom you have to find the ionization energy. So now this Z solution. Now Ex equal to, this is now your 40.8 electron volt, or this is now first excitation energy. Remember, first excitation energy. So first excitation energy of hydrogen atom. This is now hydrogen atom. This we have this En minus E1. This is En minus E1. This is now 10.2 electron volt. This we know. This we know. So this Z equal to square root of Ex minus En minus E1. So this Z equal to square root of, this is now 40.8 upon 10.2. So now this Z will be 2. So Z equal to, this is now square root of 4, or this Z is equal to 2. So now the ionization energy EI is equal to 13.6 into Z square electron volt. This is the formula. 13.6 Z is equal to 2. This is now your so much electron volt. This is equal to your 2 square. So 13.6 into 4, 4 6 is 24, 12 and 2 14, 4 and 1 5. So much electron volt. This is now ionization. This is the answer. So for any given question, if you are given the excitation energy, then for the same atom you have to find the ionization energy. This is what to understand. Moreover, this can be also seen that what is the name of the element for which we are finding the ionization energy. Then you can see that this Z is coming out to 2. So this is for helium ion. This is what? Helium ion. Because helium has 2 electrons in the first state. So if one of the electron is taken out from the atom, then 1 electron will be left. So whatever will be the spectrum, that will be equivalent to the spectrum of the hydrogen atom. So this is what we are finding, the ionization energy of the hydrogen ion. This is now for helium ion. So this is naturally Z equal to 2 corresponds to helium ion. Z equal to 2 corresponds to helium ion. So also it may be asked that what is the name of the element corresponding to this ionization energy. So according to Z, you find the name of the element. So thank you very much.